Welcome back. In the last lesson, you learned about the stack data structure. In this lesson, we'll learn how to write programs to work with a stack in Python. So first, we're going to make an empty stack with no data in it. And then we're going to write program commands to push data to the stack and pop data from the stack. And I'll leave you with a couple of programming challenges to stretch you a bit further. Just to remind you, a stack is a data structure, a linear data structure, and data can only be added or deleted at one point, which is called the top of the stack. And the two commands are called push and pop. So here's an example of an array in computer memory. This is the basic structure of the computer's memory. There are a large number of numbered data locations, and data of different kinds can be stored in those locations. So this is what we're working with when we work with data inside the computer. With a stack, data is stored in memory locations, but we only remember one value. The value is the data location at the top of the stack. In my programming, I'm going to use top to indicate the spare data location at the end of the stack. Some programmers use top to represent the final data value in the stack, the letter C, so top would have the value 2 in that case. You can write programs either way. I'm going to use one way, and the other way is perfectly valid, and you can write programs that way as well. And in fact, if you want a second challenge, you could try that style of programming. But anyway, enough said. In my programs, I'm going to use top to represent the empty space at the top of the stack where we can push new values. So here is a starter program. If you're my students, I've created this for you. If you're not, you can very easily write a program like this. I've created an example array with 6 data locations. In real life, of course, you'd have far more than 6. And my pointer at the top is pointing to, as I said in the last slide, the empty space where new data will be added, which is position 0 of the array. So that's all I need to do to create a stack, have an empty array and a pointer that points to the empty value at the top of the stack. Obviously, my stack's empty at the moment. And if you're my student, when you run the program, you'll see a very simple little menu. You can choose to push or pop or exit from the program. Again, if you're not my student, you could very easily write 4 or 5 print commands to make this menu happen. And then we're inputting the user's choice, 1, 2, or 3. So now we're going to write code. If the user chooses 1 from the menu, we're going to get some data from them and push it to the stack. And if they choose 2, we're going to pop some data from the stack. And the whole thing's in a while loop, so this will just keep repeating, and you can keep pushing and popping to and from the stack. So we're going to write that program now. First of all, we're going to write the code to push. So for example, if we push D to the stack, the top of the stack is location 3. So we put D into location 3, the location of the top, and then the top moves up by 1 and is now pointing at location 4. So we're going to write that code. It's very, very straightforward code. In fact, if you'd like to try and write that code without looking at my answer, that would be a good practice for you. I'll wait a second or two so you can stop the video, and then I'm going to go on to the next slide and show you the answer. So if we want to push to the stack, the user must input some data because we need some data to push, and then we add the data to the array at the location represented by the variable top. Top stores an integer, so in this case, if top is 3, array square brackets 3 is where the value will be added. And then, of course, we have to move the top along by 1. It goes up by 1. So it's again pointing at some empty space ready for us to push a value. So let's see what happens in the array when a value is popped from the stack. The top of the stack moves back by 1. So it moves back down the stack. The value at the top is returned. It's the output or returned value of this operation. And I've shown the value disappearing from the stack. In fact, the computer probably wouldn't clear that data location. It would just ignore the value that's there. The pointer is now pointing at location 3, and that means the next time a value is added to the stack, it will overwrite that data location. In the meantime, the data probably just sits there being ignored by the computer. So can you write code to pop a value from the stack? I'm going to put it up on the screen in a second or two. So if you want to pause the video and write that code now, or write it on paper or in your Python program, and I'm going to show you the answer in just a moment or two. So here it is in my program. If they choose 2 from the menu, that means that we're going to pop a value from the stack. And what we do is move the top down by 1. That value is now the top of the array or top of the stack. So we record that value, we store that value and output it. Notice I haven't bothered to delete the value from the array. I'm just leaving it there and the computer will ignore it. And next time we push a value, it will overwrite that the data at the top of the stack. There are some restrictions, of course. If the stack is full, that is, you've used up all the available data locations, you can't push a new value. And if the stack has no values in it yet, if the stack is completely empty, as it is at the start of the program, you can't pop values from it. And in fact, if you try in either of these cases, you'll get errors. So, how can we tell if the stack is full or empty? As you know, an array never changes in size. It still has the same number of data locations, whether those data locations have got data stored in them or not. So how do we know if the stack is full or empty? I'll show you on the next slide. So if you want a bit of a thinking challenge, see if you can answer that question before I move on. The way that we can tell is if the top pointer has the same value as the size of the array, then it's reached the end of the available space and the stack is full. So let's say our array has got 100 items in it. If the top pointer reaches the value 100, then we can't add any new values. The stack is full. However, if the top gets right down to position 0 of the array, then our array is completely empty and we can't pop any more values from the array. So we started by creating an empty stack, which is basically just an array of empty data locations plus a pointer which starts at the very bottom, first value of the available locations. We saw how to push. What we do is add a value at the top and then move the top up by 1. And in reverse to pop, we move the pointer down 1 and return the value at the top of the stack. I also briefly explained how we can add a check before we push or pop. So before we push to the stack, we can check to make sure that the stack isn't full. If it is full, we can't push. And before we pop, we can add a check to see if the stack is empty, because if the stack is empty, we can't pop. There are no values left to pop. Okay, so I'm going to leave you with an activity. Create or open the program that shows an empty array with a stack pointer, and write code so that the user can push new values and pop values from the stack. And then improve your program by adding checks that whether the stack is full or empty. Remember, if the stack is full, we can't push, and if the stack is empty, we can't pop. I've got some extra challenges on the next slide, so if you've done that and you want extra challenges, I've got one more task for you. Instead of adding this code inside the main program, write some stack functions, push, pop, is empty, is full, and a final stack function that some stack programs have, which is peek, and peek tells you the value at the top of the stack without deleting it, so without moving the stack pointer down. Okay, so push would take a parameter and add it to the stack. Pop has no parameter but returns the value at the top of the stack. Is empty and is full return Boolean true false values to tell you if the stack is full or empty. And peek will return a value without moving the stack pointer. So there's quite a few different programming challenges for you. I strongly urge you to try and do those and to create a complete stack program. Only by doing this will you fully understand the stack, and it's also very good programming practice. In the next presentation, I'm going to move on to a new data structure, the queue. So get familiar with the stack, get comfortable with the stack, and then join me again in a new lesson to learn about a new data structure. So bye for now.